Hey, hello. Here we are in Advanced Algebra 2, and today is polynomial long division. This is going to be quite a ride, let me tell you. We're going to do some things. It might look a little frightening. If you were paying close attention in 4th grade, it should look like long division with numbers did, but 4th grade was an awful long time ago. So, let's get started. Now here for the first example, we have this thing, I guess a cubic, x to the third minus 4x squared minus 19x plus 9, divided by x plus 3. So we're going to divide it, which means long division. And it's divided by x plus 3, so the denominator, which is the divisor, technically, goes on the left of the little long division sign, and the thing on top we're dividing gets, oh goodness, gets underneath. Okay, now this is going to be tricky. What we're going to do is we need to figure out a number that goes up top. So some sort of number is going to go up top here-ish, and it's going to multiply by these things, and it's got to sort of recreate what's going on here. Now this looks like some kind of draw play that's guaranteed to lose 5 yards. So instead, let me just kind of show you what's happening and try not to be too scared as we proceed through it. So the first thing we're going to do is x squared is going to be part of our answer. And the reason why is, remember before I was drawing arrows, x squared, part of the answer, is going to multiply by each of those two terms, x and 3. They're not very exciting terms, but they are terms nonetheless. So we're going to multiply them. And x squared times x is x cubed. X squared times 3 is 3x squared. Now that x squared, which is part of our answer, has kind of taken care of creating an x cubed and a 3x squared. So we're going to subtract that much away. Now the good news is that the x cubes cancel, and they have to always cancel or you've done something terribly wrong. And then on the x squared side, we had negative 4x squared. We subtracted 3x squared to create negative 7x squared. And then we'll just kind of go ahead and bring down the unused parts of the exercise for now. Alright, now we're going to do it again. We're going to add to our answer, throw something down up here that will multiply around over here, and all of a sudden again I'm pretending I'm some sort of coach. I'm not. Okay, so 7x is the magic term because that negative 7x multiplies by the x to make negative 7x squared, and it multiplies by the 3 to make negative 21x. So the x squared part, the green one, kind of created an x cubed and a 3x squared. This negative 7x part creates a negative 7x squared and a negative 21x. So we'll subtract those off. Well, the x squareds will cancel, and again that leading set, the front terms always have to cancel. And then negative 19x minus negative 21. Notice there's a minus on the outside. It's hard to remember, but so important. So it creates positive 2x plus 9. Okay, so again, we're going to do it where we put something down as part of our answer and see what happens. So the thing we're going to need is a 2, because that 2 is going to multiply. I'll show you again. The 2 is going to multiply by the x and by the 3. And again, that's terrible diagramming, but when it does, it creates a 2x and a 6. So we'll subtract that off, see what we have left over, which is just the number 3. Now the number 3 is too small, and it's not that 3 itself is a small idea, like 3 sheep or 3 pieces of apple or who knows what, but it's that I was dividing by x, and 3 is just a number, and x is a thing like more powerful than just a number. So we're done. And in fact, the 3 is our remainder. And again, as I said before, if you remember 4th grade, there were remainders instead of just fractions for everything. And then the top stuff is our answer, really-ish, which is our quotient. And again, that's a magic math term for dividing. So that means, so this whole huge construction I made that looks like an inverted triangle, that's the work. So the original problem, and I'm just rewriting the problem, x cubed minus 4x squared minus 19x plus 9 divided by x plus 3 equals, in our answer, our quotient part is x squared minus 7x plus 2, and the remainder part, which is 3, which hasn't been divided by x plus 3 yet. So the remainder part needs to still be divided by the divisor. That's the first one. I've got a few more because they're all just slightly different, and it's so confusing at first. Okay, here's example 2. Another cubic, because it's 6x cubed plus blah-bitty-blah-bitty-blue, divided by another linear, because it's just an x. So long style dividing, 3x minus 2, 6x cubed plus 2x squared plus 11x minus 10. Make it longer. Okay. Okie dokie. We're looking for that top number, which will recreate the 6x cubed. And this time it's going to be 2x squared, because the 2x squared multiplies by 3x and by the negative 2. And when we do that, erasing the arrows because they're ugly, you'll see 6x cubed minus 4x squared. We'll subtract them away, and that creates 6x squared plus 11x minus 10. Again, I'm just kind of bringing down the extra stuff that's kind of feeling lonely, because you want to bring it along. It doesn't get its feelings hurt too much. Okay, now we got to make 6x squared, so 2x, because 2x times the 3x makes 6x squared. 2x times the negative 2 makes negative 4x. Subtract, which means that beginning stuff cancels. It always has to. 15x minus 10. Okay. Now, what's next? 5, because then 5 times 3x is 15x. 5 times negative 2 is negative 10. Subtract it, and boom, and boom, and whoa, that's a 0. Okay, hey, that means there's no remainder. Basically, divided perfectly. Happiness. Okay, so rewriting what we have here. Again, I'm just rewriting the problem. It's not terribly exciting, but I want to just kind of show off that this dividing problem creates an answer, a quotient of 2x squared plus 2x minus 5. I'm sorry, plus 5. And we're done. By the way, special bonus, it's not actually part of today's lesson, but it will be so drastically important later, and it will be highlighted then, so don't stress about it. But this means that 3x minus 2 actually factors into 6x cubed plus 2x squared plus 11x minus 10, right? 3x minus 2 is actually a factor of it, and that's so important later, but don't hurt yourself now, falling off that division. Okay, next example. Another thing, but oh my gosh, look, we're dividing by x squared minus 2x plus 1. We're dividing by a quadratic. Oh my gosh. Okay, so the divisor looks longer, but, you know, other than that, it's the same setup. I need the thing up top, and then this is where I'm going to draw one of those bad football plays again. Need a thing up top, but it's not going to multiply by the 2 terms, because there's 3 of them now. Okay, that one just missed. Bad aim. Multiplies by the 3 terms up top. So, the number is x. Hey, that's not even a number. Okay, the mathematical construction term thing is x. Because x multiplies by x squared to make x cubed, x multiplies by negative 2x to make negative 2x squared, x multiplies by 1 to make x. Subtract it away, the x cubes go bye-bye, and we have negative x squared plus 2x, and then that minus 1, you know, you feel for it. There it is. Okay, so we can do it again. Something up top needs to multiply by those things. Oh, minus 1. Yeah, that'll work, because negative 1 times x squared is negative x squared. Negative 1 times negative 2x is positive 2x. Negative 1 times negative 1. So I feel like I'm perhaps just talking too much and not showing enough. This negative 1, and I know it says minus 1, but come now, it's a really negative 1, multiplies by the x squared, by the negative 2x, and by the 1, and then that all kind of creates what's going on down there. Okay, see, now they're at least going past the line of scrimmage. All right, so there we are. Subtract them away, and gone and gone and more gone. Again, no remainder. There's nothing magic about it being no remainder. It's kind of a sign of success, but that doesn't mean you did the problem right. It means I made the problem in a manner that would make you happy at the end. I don't know. Speaking of happiness, we'll just throw in a little smiley face. Okay. So then again, I'm rewriting it just to kind of be able to show the answer and highlight what's going on. We have this cubic thing, x cubed minus 3x squared plus 3x minus 1, divided by this quadratic thing, and it creates x minus 1, the quotient on the top of the division sign. That's it. All right. The speed is picking up. Your sense of having any idea what the heck is going on should hopefully be picking up too. So here we have x to the 4th. Yeah, I would do that, wouldn't I? Yep, okay. X to the 4th plus x squared plus 1. If you're focused on the fact that it says x to the 4th, you haven't yet noticed what's actually the point of this example, which is it's missing stuff. Not the x squared minus x plus 1, but look at another one. X to the 4th plus 0x cubed plus x squared plus 0x plus 1. It is highly recommended that you write in zeros for missing terms as you move your powers down. So for no 3's, so okay, no 3's, to no single powers, so 0x, and then constant that was there, the 1. It doesn't make it wrong to not put in the extra 0 terms, but it makes it so much harder to stay organized. So, if you are a little bit arrogant about your work and you've always been annoyed at how math teachers tell you how to organize yourself, you can always try to go against my suggestion here. But at the same time, if you have any sense of trying to keep things organized and when you're in strange lands and meeting new people, this would be it. But hey, everybody has a different way of rolling. So, something up top needs to multiply by x squared to make x to the 4th. Aha! X squared. Because x squared times x squared is x to the 4th. X squared times negative x is negative x cubed. X squared times 1 is positive x squared. Again, I'm going to pretend I'm a football coach. Decided some sort of end around, maybe. Anyway, there, and that multiplies to make those 3 things. So, we've created that much with just the x squared, so let's subtract that from the original problem. Be careful about the fact that it's minus, especially when you have negative things in there. For example, on the x cubes, it's 0 minus negative 1 to make positive 1. It's the sort of thing that's insulting when you have it, and if you don't have it, you gotta pay careful attention for it. Hey, look, the x squared's went away, even though we don't really care. I mean, we're not there yet. So just, again, recommended that you write in 0x squared. It helps you stay organized. You should be slightly less unhappy as a result. Okay, something goes up top that multiplies by all that stuff to make 1x cubed. X. Because x times x squared is x cubed. Yep, okay. And then minus x squared, because x times negative x. And then plus x, because x times 1. Oh my gosh, this is fun. Now let's go ahead and subtract that away. And then goodbye x cubes. So 0 minus negative x squared. 0 minus 1, negative x. And then 1. Man, this 1 is, I just feel for it. It's loneliness. I should have drawn some arrows showing, frankly, how little loved that 1 is. Oh well, nobody likes it. What's the song? I guess it'll go eat worms or something. Anyway, so let's go ahead and up top, something times the x squared minus x plus 1. Oh, 1, because 1 times x squared is x squared, and 1 times negative x is negative x, and 1 times 1 is 1. And we'll subtract it away, and then but you got nothing left. There's no remainder again. I'm telling you, this is getting better and better. So, rewriting it just so I can have something to show the answer off of. X to the 4th plus x squared plus 1 over x squared minus x plus 1 equals, and the answer is x squared plus x plus 1. All right, so these 4 examples have done a great job of showing the different constructions. You will potentially notice that example 1 was the only one that had a remainder. So that's nothing special about it being like an early problem or an easy problem. It's just that as the problems themselves became more interesting, they all just happen to divide in evenly. All right, 4 examples. Now, I would recommend that you look at that this is going to be the assignment. If possible, it would be wise to go ahead and do the first 3, maybe, and get started on them. Write them down. Give yourself a little bit of vertical room on the page. I mean, not a whole page, certainly, but, maybe a couple inches per problem. They don't take a whole lot of space left to right, so you could get a couple good columns in on your page if you want. I would try 3 of them. Kind of force yourself to try to carry some stuff through. If you feel like you have no idea, try 2 of them. If you feel like you have a great idea, try 3 of them. I wouldn't go much past 3 until you've confirmed that you're doing it and you've got it rocked. Not just the answers, but kind of the process is perfect as well. Hey, thank you for watching, and as always, please let me know if you have any questions.